Optimization example 2, we have approximately 1 in 4 deaths in America is caused by heart disease. A study has been conducted to see if the common goal of 10,000 steps per day is truly best for reducing risk of heart disease. So you know when you get a Fitbit, it has the goal preset in there that it's 10,000 steps. You can change it, but we want to see, is that common goal of 10,000 steps per day really the best goal in terms of heart disease? So the study assumes that the average person can only take up to 25,000 steps in a day. So yes, it's possible to take more, but if you've taken 25,000 steps in a day, you know you're feeling it. You've been doing a lot. So we're going to say that our upper bound, they can't do 1 billion steps in a day. They haven't been walking from dusk till dawn. We're going to say a realistic highest amount is 25,000. The number of deaths from heart disease, D, in thousands, related to X in 10,000 steps per day is given by this capital D of X. So if we plug in and we get D is 1, that doesn't mean just 1 death, unfortunately, it means 1,000. And if our X value we plug in is 1, that doesn't mean 1 step in a day, that means 1 times 10,000, that would mean 10,000 steps in a day. So we want to find the number of steps per day required to minimize the death rate from heart disease. So first of all, we have our objective function. It's given to us for this one. This is what we want to optimize. We want to absolutely minimize for this one. It's called D of X. It's 5x squared minus 12x plus 610. So that's good to go. The other thing we need is our interval. So our interval is representing our x values. So our least amount of steps we can take is 0. And our highest amount of steps we can take is supposed to be 25,000. So the trick here, it's not actually plugging in 25,000 because you're going to get a crazy answer here. We want to remember x is in 10,000. So I need to figure out what is 25,000 going to be in terms of 10,000. So I would divide by 10,000. Right? We said 1 stands for 10,000 because it gets multiplied by 10,000. We're doing the opposite here. We have 25,000. We want to take it back. That's really 2.5 10,000s of steps. Weird unit on this one. So 0 to 2.5 represents 0 to really 25,000 steps. So weird unit because it's in 10,000s. But there's our interval of interest. So we're going to see, first of all, what the critical numbers are. Maybe the critical number will really be 1, which 1 times 10,000 would stand for this 10,000 step goal, and we'll really minimize the death rate. Or we can see maybe that's not the actual goal we should have in terms of heart disease. So let's see what our critical number is. So our derivative is going to be 10x minus 12, which is great because we don't have an x squared. We don't have to factor. We have a linear function here. So I'm just going to add 12 to both sides. So I get 10x equals 12, and then I'm going to divide both sides by 10. So you get x equals 12 over 10, which is the same thing as 6 over 5. But because this is in 10,000s, I'm going to make it into a decimal as long as it terminates, and this one does. 6/5 is the same thing as 1.2. So are we telling people to take 1 step and then a little bit more? No, this is in 10,000s. So 1.2 times 10,000, let's just see if this is a realistic number. 1.2 stands for 12,000 steps per day. So is that on our interval of interest? Well, yes, because 1.2 is between 0 and 2.5. And also when we talk about it in terms of our correct units, it's between 0 steps and 25,000 steps. So interestingly enough, 10,000 doesn't even end up being a critical number, so we don't even have to test it. Absolute extrema comes from either our endpoints, 0 and 2.5, or maybe the absolute min is at that critical number in between. It's not going to be at any random number besides that. It's at a critical number or the endpoint. So let's see if walking 25,000 steps is really better than 10,000 or if it's 12,000. It's probably not 0. 0 steps in a day doesn't seem very good for your heart. But we plug it into the original. If you plug in 0 to the original, you get 610. Unfortunately, that's not the real number because D is in thousands. So if we multiply by 1,000, it's not just 610 deaths, it's 610,000 deaths for the people who walk 0 steps. There's their risk. So if we compare that to plugging in 1.2, let's see if 12,000 steps is a little bit better than 0 steps. I would hope it would be. When we plug into the original, we get 602.8. That, of course, gets multiplied by 1,000. And we get 602,800 deaths. There's your death rate for 12,000 steps. So better than walking 0. Let's see if 25,000 steps is even better. So if we plug in 2.5 into the original function here, we get 611.25, which isn't really the number of people because you can have 2.25 people. It's multiplied by 1,000. It's 611,250 deaths. So actually a really high death rate for walking that many steps. It's a lot of stress on your heart probably. So our conclusion, we want to make sure we answer this question. Find the number of steps per day required to minimize the death rate from heart disease. So it's not asking for the minimum death rate. It's asking for the number of steps. So our conclusion is people should walk 12,000 steps per day to minimize heart disease. And I wouldn't just say heart disease, I guess it's heart disease deaths. Kind of depressing, but we just kind of concluded that 10,000 steps per day isn't the ideal for at least the heart disease. I'm sure there's some other factor that they came up with to come up with the 10,000, but according to this study, the magic number would be 12,000 steps per day.